Hello, in this video we're going to talk about vector embeddings and specifically 3 strategies that we find helpful when speaking with clients who are getting started on their AI journeys. And in this video I'm going to assume you're familiar with vector embeddings, and if not, there'll be a link in the description for learning more. So just quickly, those 3 strategies are how you chunk your data, making sure you set enough time aside for experimentation, and finally, using the power of vector database collections, which is really about not putting all of your data into one single large collection. We'll talk about why that's important, but let's first start with data chunking, which is typically the first decision you'll need to wrestle with. So here I have some text from Wikipedia on artificial intelligence, and you can imagine any number of ways you could think about chunking this text up. You could, for example, just pick an arbitrary number of words, let's say 5 words, and start to chunk the text up that way. One issue, which is probably obvious here, is that any one of these chunks on its own really doesn't have that much context and may not be useful at all. So what a lot of folks will do is broaden that and start to chunk more along sentence boundaries, which is definitely better. What we found, however, works in a broad number of use cases is to chunk more along paragraph boundaries. So this is actually the default in LLMWare, but it's configurable. And this is one of the things you want to try experimenting with, depending on your use case. So that leads us to the second strategy, which is about making sure you've got that time to experiment. And the reason we like to talk about this is we've seen some clients make some very important decisions up front, like choosing their vendor, choosing the embedding model, and then really struggling trying to get the types of results they were hoping for out of that system. So what we recommend is actually don't assume the first embedding model you try is going to be the right one. Instead, spend a little bit more time on some pipelines where you can quickly experiment with many different embedding models to try to find one that works for your use case. And then even moving forward, once you're considering going into production, you probably don't want to assume the model and the approach you're going with now is going to be the one you want 6 months from now or a year from now, just given how fast the industry and models are changing. So you're going to want to build in the ability to swap out embedding models, re-index data, things like that. So one of the bits of feedback we get when we talk to clients about these types of things is, well, this sounds like a lot of work. Setting up pipelines where I can try out new models. Do I need to be a data scientist for that? And this is what we've tried to make as easy as possible in LLMWare so that pretty much anyone can do it. So let's take a look at some code. So this is actually a pretty complete code example. This does a few things. First, we create a library, and in our terminology, a library is just a named collection of data. Then we add in the data from a whole bunch of files, whatever we find in this particular folder here, vendor contracts. This is actually going to do that chunking that we talked about earlier. It's going to, by default, chunk along a paragraph boundary. And then this middle section here is where we're going to do the embeddings. Here we're using a named model from Hugging Face called BERT-based cased. And then in a few lines of code, we're kicking off the embeddings. And this one line here, this install new embedding, is going to create a vector embedding for every chunk that was found earlier and store them all, in this case, in Milvus. And then we can do some semantic searches and start pulling data out of the vector database and see if we get the type of results we were expecting. So the important thing to note here is if I wanted to try all of this with a different model, all I need to do, the only bit of code that needs to change is really this model name. So hopefully it's obvious that you can slap together pretty easily some loops, some pipelines, some code that will very quickly iterate, perhaps over a large number of models, to really find the one that's going to meet your use case demands. So that leads us to strategy 3, which is really about not trying to shove too much into a single collection in a vector database. All the vector databases these days will have the ability to have multiple collections. And if you're able to segment your data, you're going to realize quite a few benefits. For example, you're going to get faster searching, indexing, and vector insertion. And that's because all of these things happen in the context of a collection. Also, if you don't just have one massive collection with all of your data and it's actually segmented, then you can much more easily and robustly think about recreating vector embedding space for a given amount of data using either the same or different embedding models, as we talked about earlier. And then finally, if you're building an AI-based product, and you want to start trying out new features, again, if you can segment your data, segment your features that pull from specific collections, then it's much more easy to iterate on these features rather than have a single collection that you're worried about adding new data to, and so on. And so this is actually done for you. This segmentation is done for you by default in LLMWare. If we go back to the code, what we do is, in this case, we will take your library name and your model name, and we will create a named collection in the vector database you're using, in this case Milvus, and that's where we'll store all of your vector embeddings. So this means then that you could run this code again with a different model name, and you're going to end up with a different collection in Milvus. And then you can actually build up over time vector embeddings from different models for the exact same data and the exact same library, and start to compare and contrast. So we think this is the best approach to really build AI applications that are going to take the best advantage of vector embeddings. So I hope this quick video and quick set of strategies has helped. And if you have any questions, feel free to reach out to us at LLMWare. Thank you.